15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again. Thank you for joining us on the Space Nuts podcast through your favourite podcast distributor, no doubt. My name is Andrew Dunkley, your host, and with me, as always, is Astronomer-at-Large Professor Fred Watson. Hello, Fred.
Ta-da! Hi, Andrew. How are you doing?
I'm quite well. My third week of isolation. It's although I've had to go out to do work on occasion. I spent 8 hours driving a truck last Friday between a shop and a church. Believe it or not, our church, because we can't have services anymore, has turned into a massive storeroom.
Oh, of course. Well, that's what happens, yeah, when you've got space to spare.
Yep,
turn it into a storeroom. Should see the study that I'm sitting in at the moment. That's exactly what it is.
My wife refuses to come in here because she said it's an absolute mess, and I'm starting to agree with her.
Yeah, probably agree. I do too.
Now, this is episode 199, Fred.
Oh, that's astonishing.
Yeah.
Will we make it to 200? Who knows?
That depends on all sorts of things.
Yeah. Check in next week, folks.
Notwithstanding a global pandemic. So anyway, I'm confident we'll make it.
I hope so too.
Now, today, Fred, we're talking about a possible event involving maybe two asteroids in another solar system. They might have annihilated each other. I love astronomy. We could have seen something that might have happened at some time. We don't know when. That's astronomy.
Yeah, that's why.
That's astronomy in a nutshell.
It is.
And
it's not there anymore.
Yeah, that's right. We're also going to look at the 30th anniversary of Hubble, which by the time this episode is released will have been celebrated. But 30 years, I actually was staggered when I read that headline. I thought, no, it can't be. But yes, it is. And some questions from our audience. Brian has done a bit of a follow-up on our discussion about the Mercury mission that we spoke about a couple of weeks ago. He's a little concerned that we might have got our wires crossed and turned everything upside down. So we're going to try and clarify that. You are right and you are wrong, Brian, as it turns out. Or you are wrong and you are right. Either way, could be two asteroids.
Just to make Brian feel at home, I'm right and I'm wrong as well.
There you are. And Alistair has come up with some ideas on the expansion theory of the universe, which we've talked about many times. It's continuing to expand at an accelerating rate. But are there variables? So we'll look into that and plenty more on this edition of Space Nuts. Now, Fred, let's talk about this possible event that might have happened involving two potential asteroids in another solar system far, far away.
Indeed, we should. I'm just conscious that we might have a bit of background noise at the moment because I forgot to shut the door. So well, never mind.
No, say hi to Marnie for me.
I will.
Well, everyone knows Marnie now because she was on one of our recent programs.
That's right, she was. So you're going to shut the door. Thank you.
Yeah, I'm treating this like live radio. You know that, don't you?
Of course. Well, that's
the way I operate.
The way we should do it. That's right. So, yes, a really interesting piece of work that actually has quite a long history. It's one of these stories that has had various levels of excitement throughout its career. It's about a disk of material around a star whose name it's usually pronounced Fomalhaut. It's spelled Fomalhaut, and it is in the southern hemisphere. It's a star very familiar in our skies down here. But I think it's kind of 20 years ago or something, observations were made of this star that revealed that it had a ring of material around it. But in other words, the the residue of what we call a protoplanetary disk. This is how we believe planets are formed. Gas and dust clouds collapse. Yeah. In the central region becomes the star, and because of rotation, you get this disk of material swirling around the star, and that is called the protoplanetary disk, and that's what the planets form in. In fact, the ALMA the ALMA radio telescope, the Atacama Large Millimeter Array, which is in northern Chile, has made almost a big business of finding protoplanetary disks around other stars. Sadly, ALMA is closed down at the moment because of the COVID-19 pandemic, but we've seen many of these examples of planetary systems in the formation. So go back to Fomalhaut. It was discovered, in fact, I believe this discovery might have been made by the Hubble rather than ALMA, but this is going back several years, or virtually 2 decades, and it was discovered to have this ring of material around it. But in 2004, it was discovered that there was a planet very close to this ring, sort of on the inner edge of the ring, and observations showed us this planet rotating around the star. It actually, it offered puzzles from the word go, because there were things that seemed a bit weird about it. One of them was that the planet looked as though it was too big to be where it was, in the sense that if it was as big as it was, it should be disturbing this ring of material, probably putting a gap into it. And there was no sign of that at all. And then another problem came up when the idea of, from what was seen at first, was you've got a big planet going around a star. It's big enough to be a super gas giant. It's a large planet, which should be very strong in the infrared region of the spectrum. So scientists tried to image this object in the infrared, and if it was something like Jupiter or larger than Jupiter, you'd get a strong infrared signal. But actually, this star was completely invisible in the infrared. There was nothing there. So that sort of made people wonder what it was that they were seeing. And so over the last decade or so, it has been imaged several times by the Hubble telescope, and in particular 2006, 2008, 2010, 2012, 2014. And what we've seen is this object just getting bigger and bigger and fainter and fainter. And now, ta-da, it's disappeared altogether. And so the interpretation of this, as you said, it's full of might have beens and maybes and things of that sort. But the interpretation is that what we've been seeing is actually a clump of dust, a large dust cloud, which has been orbiting on the inner edge of this ring, but doesn't have enough mass to disturb it, and is now dissipating. And in fact, is now dissipated to the extent that it's invisible. There's a lot of physics involved with this. I'm totally oversimplifying the story, Andrew, but that is the upshot. It's work that's been done at the University of Arizona. And their view is that this planet was never there in the first place. We've been observing a pile of debris. Where did the pile of debris come from?
That is the $64,000 question.
And the
or in the case of Space Nuts, a 64-cent question.
Or the 64 trillion light year question. That's the one.
Maybe.
The answer seems to be, and the physics sort of works out, that if you had 2 large asteroids, sort of several hundred kilometers in diameter, in orbit around Fomalhaut, the star, and there was a collision, then this is exactly the result that you would get. So the interpretation now is what we're seeing is the results of a bingle between two pretty big asteroids that probably wiped themselves to pieces. Now, we know, once again, from planetary our understanding of planetary origins, that part of the process involves these protoplanets, which are large objects. Actually, I think protoplanets are usually, or planetesimals are usually considered to be bigger than these asteroids might have been, because you've got to account for the amount of dust that you're seeing, the length of time it takes to dissipate, and all that sort of thing. But that seems to be the current answer of why we have seen this planet that is not a planet and is now no longer there anyway, a collision between two asteroids.
So we started out thinking it was a gas giant, then we started thinking that it was probably a rocky planet the size of Earth, and now we think it's neither, and it's two asteroids that smashed into each other over a parking space.
Yes, very likely. That's probably the... well, in a sense, that's right, because they were both trying to be in the same stable orbit around the star. So think of that as a parking space, and you've got exactly the analogue that you've suggested. You see, this is why you're on the radio, Andrew, because you go straight to these beautiful examples.
I always find the lowest common denominator. I do. But it works for me. If you want something more intellectual,
don't listen to Space
I'm not
Nuts.
Your man. All right. But they've put up a great series of photos to show what happened since 2004. And you can easily see why initially you'd think it was a planet. It's big, it's circular, it's bright, but over time it sort of just flickers away like smoke, doesn't it?
Yep, that's right. Smoke and mirrors. Yeah. This is all, there are a few news sources that have this out, but you can go to the story on the Hubble Space Telescope website, spacetoLescope.org.
Okay, very good. All right.
Yeah.
Well, if they've got it solved, we may not need to talk about this one again, but they could change their minds. They could change their minds.
There'll be something else, Andrew, don't you worry.
For sure. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson, episode 199. Let's take a break from the show and hear a word or two from our sponsor, Grammarly. Now, I have to say I'm a big fan of Grammarly because I've been using it for a few years now. Very helpful for authors, but also really good for everyday life. They've saved me on a few occasions, particularly with spelling, but also with a few issues that didn't quite make sense. It's built by linguists and language lovers, and Grammarly's writing app finds and corrects hundreds of complex writing errors, so you don't have to do it yourself. Word by word, day by day. You can easily copy and paste any English text into Grammarly's online text editor, or just install Grammarly's free browser extension for Chrome, Safari, Firefox, and quite a few others. Grammarly's algorithms flag potential issues in the text and suggest context-specific corrections for grammar, spelling, and vocabulary. Grammarly explains the reasoning behind each correction so you can make an informed decision about whether and how to correct an issue. Grammarly helps you write mistake-free Gmail, Facebook, Twitter, LinkedIn, and nearly anything else you write on the web. For you, the listener of Space Nuts, Grammarly is offering a free download of the Grammarly software. So if you'd like to download Grammarly today, go to getgrammarly.com/spacenuts. Again, that's getgrammarly.com/spacenuts to download Grammarly for free and let them know you came from us. I'll include the link in the show notes as well. And now, back to Space Nuts.
Okay, we checked all 4 systems and skiing with a go.
Space Nuts.
And hello to all our YouTube followers. We have a very solid following on YouTube these days. I love the way they do it, Fred. 1.21 thousand we have.
Oh, good.
1.21 thousand followers on our YouTube channel.
Could be 1,210.
Could be. YouTube.com/C/SpaceNuts. You can hear all our back catalogue. I've always wanted to say that. Our back catalogue on YouTube is there. You can press play and just let them run. There's a play all option. I love that. But I think you get to listen to them backwards. And I'm not talking from episode 199 down to 1. I think they just play backwards. I don't know. No, it's good. It's really good. So thank you for following us on YouTube or Twitter or Instagram or Facebook or wherever it is you listen to Space Nuts. Now, Fred, we're going to talk about an old friend. We've already mentioned the Hubble Space Telescope, but I was stunned and amazed when you sent me the idea of discussing this, that Hubble turns 30 on the 24th of April, which may or may not have already happened depending on when people listen to this podcast. But 24th of April, so it all began in 1990.
It did. And it was very exciting, of course, because we've been, in the world of astronomy, we've been waiting for this for a long time. And it was delayed, of course, because of the Challenger disaster in 1986. The telescope was supposed to be launched, I think, in 1986, but in the aftermath of the Challenger disaster, it was delayed until the 24th of April. The story, I'm sure you and I have spoken about this before, that we were privileged in the world of astronomy to have daily updates from the commissioning of the telescope. It was launched on the 24th of April, entered orbit shortly after that, or the final orbit. It took a little while, and it also started then a process of commissioning. And we were all kind of waiting for these gorgeous images, which never came, because it turned out that there was this error with the mirror, the world's most perfect mirror made to the wrong prescription, which was eventually corrected in 1993.
And you know how hard it is to get an optometrist into orbit. That is just not easy to do.
It was effectively a contact lens that was put into orbit, but that's right, yeah. It's the space shuttle mission that did that was, I think, one of the great feats of all time, because the Hubble is actually in quite a high orbit. If I remember rightly, it's about 600 kilometres, which was certainly at the extreme end of the space shuttle's range of operation. Anyway, that's the backstory. What we now have, of course, is 30 years of fantastic work, not just in imaging, but in spectroscopy and all the other, clever bits of science that astronomers do to probe the universe. But we've got this huge, talking of back catalogues, Hubble's got a back catalogue that makes the space not one like peanuts. There you go. There's an allegory for you.
Friend. Good. You could get a job on radio with jokes like that.
I could. Yeah, just don't give up your day job. No. That's always the answer. So I was asked, I was very honoured to be asked by the ABC, the Australian Broadcasting Commission, to choose my top 10 Hubble images, which I did.
Wow.
And they're now on the ABC's website. And I thought just very quickly, it might be nice just to go through them and tell you why I think they're exciting. If you think that is appropriate to do.
It's absolutely appropriate, Fred, and people could probably find this website and look through them while they're listening to the podcast, and it's on the abc.net.au/science page or slash news. /science, and right. You'll find the story there, or just do a search for it. I think if we just give the title Hubble Space Telescope turns 30 in your search engine, you should find it, and put Fred Watson's name in there and it'll turn up. The web crawlers have probably found that already. And I think a lot of people will recognise these images. They have become famous, a lot of them.
Yeah, they're iconic, absolutely. So what I tried to do, they've actually come out in a slightly different order from what I selected them, because I was strictly in distance order, but that's all right. I have no problem with the fact that they're just a little bit changed, because it makes for artistic beauty is probably the word, or completeness. How's that? Yes. But we started off with Jupiter. There's a marvellous image of Jupiter, which was taken actually, I think, in 2016, as part of a series of images that were in preparation of the Juno spacecraft, which is currently in orbit around Jupiter. But this is Hubble at its best because it combines a visible light image, which shows the richness of the detail in the cloud belts, which of course we're seeing in even more detail now from the Juno spacecraft. But Hubble's view shows the whole planet, all the cloud belts, a great red spot there looking very red and a little bit less great than it used to be, but I think that's stabilized now. But because Hubble has this extraordinary capability in the ultraviolet region of the spectrum, which actually won't be replaced when it finally, when its demise comes about, we will lose that access in detail to the ultraviolet sky. Because of that, there is superimposed on this image of Jupiter, we've got the northern aurora, the north aurorae around the north pole of Jupiter, which emit strongly in the ultraviolet. We can see them very clearly. It's an amazing image, which caught my eye as one of the iconic ones. And perhaps the most iconic of all the Hubble images, the famous Pillars of Creation image, which was made very early in the piece. It's the central part of the Eagle Nebula. That has been repeated with a new camera that the telescope was fitted with several years ago. So we've got this detailed picture of these three pillars of dust, which contain embryonic stars at their tips. But this is now combined, and in some browsers you might be able to flick across and move your cursor across, and you can switch between the two images. Yes. It's now combined with an infrared image.
Oh wow! Look at that. So if you're looking at the left-hand version of the image, you see the pillars, the dust clouds, and a few stars. But if you slide right, it just changes the picture entirely. That's very clever.
It may not work with all browsers. I noticed with a different browser that I sometimes use
Chrome, so it works with Chrome.
Yeah, and it works with Firefox too. So the infrared image, essentially infrared light penetrates the dust, and so what you see is these outlines of the dust clouds with almost like a ghostly view of them, and you can see the newborn stars at their tips, certainly in some of them. But what also is clear with this is that the background dust has almost been swept away, and you've got this glittering background of stars there behind the pillars. Great stuff.
It is
very nicely done,
and it is one of the iconic images from Hubble. I think most people will recognise. Yeah. Next one, Fred.
It is it's just a star field, but I love this because it kind of reminds me of why I did astronomy in the first place. It's actually the central region of a very rich, what's called an open cluster, a fairly young cluster of stars. This is a big one. It's got kind of 10,000 stars in it. But it's so you've got all these lovely different coloured stars, but you can also see right through it to distant galaxies, which are in the background there. It's about 13,300 light years away. Very much, very much a Hubble product at its best. Absolutely crisp imaging, showing a kind of cross section through this open cluster. Then there's one of my favourites. This is actually on the front cover of the US edition of Exploding Stars and Invisible Planets, and it's the star V838 Monocerotis, usually abbreviated to V838 Mon, and this is not it looks like a star embedded in a cloud of dust. That's what it is, but the cloud of dust that you're seeing is illuminated really in an unusual way, because this star had an outburst a few years ago, 2002. It sent out this kind of pulse of light. It got to, I think it's, a million times brighter than the sun or something like that. It was colossal, but brighter than the sun intrinsically. And so what you have is this expanding shell of light, which illuminates the dust cloud, almost like so as you watch it over time, it changes. It's almost like computer tomography. It's getting slices through the dust cloud. Then the next one I chose was M81, Messier 81, which is a perfect spiral galaxy. It's the most beautiful spiral in the sky. I think it's in the northern hemisphere in the constellation of Ursa Major. Perfect spiral arms, a perfect disk of material. I just think that's elegance personified in terms of galaxies. And then really looking much further out into space to a distance of 4 billion light years. This is a cluster of galaxies that's called Abell 370. It's a very rich cluster. It's just in the same way that the open cluster of stars dazzles the eyes. This one dazzles the eyes, but with galaxies rather than stars. But it's important because we've got all these little arcs of light, which are the lensed images, gravitationally lensed images of galaxies in the far background. A really amazing image, which I am very fond of. Once again, that's actually in the book. It's one of the pictures we used. Yeah. Then a nebula with the memorable name of LHA 120N150. That nebula is in the Large Magellanic Cloud. It's not particularly spectacular. It is a cloud of gas. It looks a little bit like a butterfly because of the dark dust lane in its middle.
I thought it looked like a Portuguese man of war, to be honest.
Well, yeah, in fact, I suppose the butterfly is upside down, so it probably does look more like a Portuguese man of war. Yeah, but what I like, again, is the fact that this is embedded on a lovely field of stars, but it's got 4 bright ones surrounding it in a perfect parallelogram, which for some reason reminded me of Art Deco jewellery. It's got that look about it of symmetry that that era loved. Moving on, another perfectly symmetrical thing. This is the Einstein cross, or one of the Einstein crosses. What you've got here is a bright point of light with 4 sort of similarly bright points of light around it in this perfectly symmetrical quintet. And it looks like, we've got this quintet of 5 stars. Why are they like that? But actually, it's not. Once again, this is due to gravity, to Einstein's relativity. What's in the middle is a galaxy, and the 4 images that surround it are actually 4 images of a very distant quasar, which is almost directly behind the galaxy.
Oh, okay.
So the light is lensed. I remember we got very excited about this sort of thing back in the 70s and 80s when they were first starting to be found. Not so much perfect crosses like this, but pairs of quasars. The reason why you can tell, apart from the fact that theory works, but the way you can tell that this is the same quasar that you're looking at, and quasars are the delinquent cores of young galaxies, very bright in light and radio emission, but they vary. And so you can see these things varying up and down in brightness. But because those 4 images have all taken a slightly different path, the light has taken a slightly different path around the lensing galaxy, they're out of sync with one another. So you see the same up and down traces in brightness, but they're actually staggered. And that's the kind of clinching proof that you're looking at the same object, because its brightness is going up in the same up and down in the same way, but with the slightly out of phase, because each one of these has taken a different path past the galaxy.
Fascinating. I think that's it's a really amazing image too. And to think you're only looking at 2 things technically, but there's 5 separate parts of the image. Yeah,
that's right. So the next one is another very famous set of images, the exploding star, the supernova 1987A. When Hubble came online in 1990, it had faded back to much lower brilliance than it had in 1987. This is in the Large Magellanic Cloud. But the Hubble, with its exquisite imaging qualities, could actually reveal the details of the remnant. And once again, we've got this sliding cursor arrangement here. And I need to, I was going to do this at the end, but I'll do it now. put up a big thank you to the person who actually wrote this website and prepared it, and that's Janelle Whirl, who's part of the ABC's science unit. She did all the arrangement of these images, and it's thanks to her that we've got this lovely sliding cursor view of the supernova remnant showing what looks like actually the central region is a blob surrounded by a ring of material. And what's happening here is we're seeing the shockwave from the explosion hitting a cloud of debris that was emitted by the star before the explosion took place. So it's celestial fireworks in a big way.
Yeah, it's spectacular.
And finally, the last one is the extreme deep field, which is looking back in time, almost the full history of the universe, probably 13.2 billion years of the 13.7 billion year history. We see back to these infant galaxies, the little ragged blobs of light, which have not yet got the beautiful spiral structure that some of the later ones have. So it's a very deep, it's using the imaging qualities of the Hubble to make a very deep image back in time, almost to the birth of the universe. Extraordinary stuff.
It is rather. I have a weird question for you, Fred. Who owns these photos?
So they actually are NASA and ESA, the two agencies that run the telescope, but they are freely available, as with all NASA images. All you need to do is credit them, and that's what we do all the time.
Yeah, they're fantastic. We might just put that link on our website so people can have a look at these while they're listening to the podcast. I think that would be the way to do it. And they can just scroll down and slide across those two photos that have got alternative viewpoints. Yeah, great job.
And once again, thanks to Janelle from the ABC for first of all inviting me to do it, and secondly putting it all together. It's a great website.
Yes, and of course Hubble coming towards the end of its life and will be replaced by the James Webb Telescope, which, as we've discussed before, has been delayed, but it promises to take all of this research to a whole new level, doesn't it?
I think that's right, yes. It's still due to launch next year.
Okay, well, we wait with bated breath. But
fingers crossed. Take
a look at these images from Hubble, some of the greatest photos of the universe you will ever see. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
Once again, a big hello and thank you to our patrons. We were asked some time ago from the audience how they can support Space Nuts, and that led to us creating a Patreon account, patreon.com/spacenuts, where you, the listener, can choose to put a few dollars in our tin. It's optional. So thank you to those who have certainly done that with enthusiasm, and we love you for it. And of course, as a patron, you get bonus material, you get the commercial-free access, and you get early access to the podcast on the weeks where we can actually record it early enough for you to get early access. But yeah, we do appreciate your support. Thank you for being a patron. If you'd like to be a patron, or at least check out the option, patreon.com/spacenuts. Now, Fred, we've got some questions to tackle, and you've been a very naughty boy, it seems. Brian Stevens has emailed us. Hi, Nuts. Fred is usually amazingly good at explaining complex scientific theories and occurrences in simple, easy-to-understand language. That's because he's talking to me, Brian. You've got to talk that way. However, I fear he may have confused some of the audience, including possibly Andrew, well, that's easy, with his description of BepiColombo's path to Mercury. He kept referring to its close encounters with Earth, Venus and Mercury, giving it boosts. Not sure about the one with Earth, but the other encounters, especially the 6 with Mercury, are breaks, not boosts. He did mention slowing it down, but kept saying the slingshots gave it boosts. Might be useful if he clarified this in the next episode. Yes, we're going to do that right now, Brian. Explain yourself, Fred.
Okay. So it's totally counterintuitive, but in order to get a spacecraft into the inner part of the solar system, you've got to speed it up. You'd think you just kind of let it go from Earth and drop it towards the center. But the process of these one encounter with the Earth, the two encounters with Venus have actually given energy to the spacecraft in terms of speeding it up to go into the inner solar system. But the question is right on the money. I'm sorry, I don't know whether you can hear that, Andrew, but I've just got noise from a website that I was looking at.
Oh, okay. No, didn't hear it.
Okay, good. That's because I was going to, make the direction. I beg your pardon. I've forgotten the name of our listener.
Brian.
I thought it was Brian. Yeah, I was going to say Brian, and I thought I'm mixing it up. Brian, sorry about that. I apologise. Have a look at the ESA website on BepiColombo's trajectory, and you can see quite clearly that. You probably look at you can look at the numbers, but there is a lovely animation, which is why the music was playing in my ears there, and I couldn't hear Andrew. The animation shows certainly those encounters with the planets Earth and Venus actually speed up the spacecraft to push it into an orbit, essentially to basically match the orbit of Mercury, which of course has a much faster orbital speed than we have here on Earth because of Keplerian mechanics. But you're quite right that the encounters with Mercury itself are all about slowing it down to bring it into the region where it will be captured by Mercury's gravity. So it's a complicated process. And thank you very much for picking me up on that, because I think I oversimplified it. I probably am doing again, but I certainly did before. It's clear, though, that if you have a look at those animations, then you can sort of see what's happening and see how these slingshots work. So you can, yes, you're right. You can do it either way. You can boost, the speed of the spacecraft, or you can reduce it. And that's what is being done here, certainly in the case of Mercury.
Okay, so speeding up around Earth and Venus, slowing down around Mercury so that it can get into an orbit.
Exactly, that's right.
All right. So there you are, Brian. Hopefully that cleared the air, and thank you for bringing that up. And we'll move on to Alistair Smith's question. Hi, Andrew and Fred. Thanks, your reports and explanations that are presented in a manner that ordinary people can enjoy and understand. Oh, I'm glad. He's asking about accelerating expansion of the universe. We are told that after the Big Bang, there was an initial very rapid acceleration and expansion, followed by a deceleration of expansion, and now a more moderate acceleration and expansion. Is that correct? On a recent Space-Time podcast, Stuart Gary reported that the acceleration of the expansion of the universe varied depending on which direction you looked. It can be imagined that there are other Big Bangs forming other universes around our universe. Similarly, it can be imagined that other universes could be collapsing around us. These events would be deforming our universe. Could this explain the varying acceleration of expansion of our universe and therefore dark energy? The answer is, I think, that it's possible to know. Impossible to know, sorry. So, well, maybe it's impossible to know, but Fred's going to try and answer it anyway, Alistair, so we'll see how we go.
Thanks very much for that, Alistair. I appreciated the question. And you quoted Stuart Gary there and the podcast suggesting that the acceleration of the expansion varies depending on which direction you look. Now, this was something I hadn't heard about. So I chased that up, not through Stuart Gary, but just by looking for anisotropy of acceleration, because anisotropy is the big word that means different in different directions. Anything that's isotropic is the same in all directions, but if it's anisotropic, it's not. And that was the first I'd heard of it, but it comes about from a paper that was published last November by a group of people, including scientists from the University of Oxford and some from Paris and Denmark, which is all about they're presenting evidence for, as they call it, anisotropy of cosmic acceleration, the suggestion that the acceleration rate is different depending on what direction you look in. Now, let's just backtrack for 1 second here, because the expansion itself, as far as we can tell, is the same in all directions. That is one of the, it's one of the major observations that we make. When we look, we believe that we are finding an expansion that is the same in all directions, more or less. Yeah. But we also know that the expansion is accelerating. You can look back, 4 or 5 billion years and see that it was actually less then in its acceleration. The expansion speed than it is now. Mm-hmm. But this was the first time I've seen the suggestion that the acceleration itself is not isotropic. So I looked at the paper, and it's quite interesting. It's got lots of very complex calculations in. But what I did was I got in touch with a colleague and friend of mine who is one of the world's leading cosmologists, and said, so what about this? And he did respond. He said he's still actually working through the paper, but he said it got off to a bad start because of some of the assumptions that were being made, in particular in terms of frames of reference and things of that sort. So I suspect he's not convinced. I hope he'll get back to me with any further thoughts he has. I suspect he's not convinced, but I also think that the cosmological community in general is not convinced. And that's why we haven't heard of this paper until now, when it was published in November. So it seems like, this is, something that often happens. You get people who are looking for really small signatures in our understanding of the way the universe is behaving. I for many years worked with a scientist who had similar ideas about our galaxy expanding, which was certainly counter to common, that what was accepted as knowledge then. And it turns out that the community was right, and he wasn't. Very interesting guy, but he was a great teacher as well. He taught me about how you deal with data and how you try to avoid putting your preconceptions on it, although in the end that turned out to give a different answer from what he expected. I think this might be the same too. It's something where you're teasing information that might not really be there. Very interesting stuff, though, and it's it's challenging. You need people coming along with this kind of thing in order to challenge the global view that we have. Yeah. It's how science progresses. Just going back to Alistair's original email. Alistair says the Big Bang, there was very rapid acceleration in expansion. That's what we call the period of inflation, followed by a deceleration of expansion. That's correct. And now the more moderate expansion in acceleration, that is actually exactly what the worldview is at the moment. We still don't understand the mechanism that causes the expansion of the universe. We call it dark energy, but we don't really know what it is. But I do think that we need to be cautious in looking at things like the acceleration varying on which direction you look in. It seems like at the moment, it seems like a very tenuous conclusion to be drawing, particularly when the cosmological community seems to disagree.
Okay, so what we're saying is that the paper may be slightly off the mark and that the expansion of the universe is isotropic.
As far as we know at the moment, that's right. But look, Alistair's last sentence is interesting. He says, I think it's impossible to know whether, things like other universes could be varying. That's certainly true at the moment. We're not looking at ideas like that, but it may well be that future observations reveal that there is an anisotropy, that the universe is not accelerating the same everywhere. And then we've really got to think about that and work out what it means. All bets will be on the table at that time.
Indeed, they will. Alistair, thank you for your question. Created some fascinating discussion. Now, I will remind people not to forget, which is the same thing as reminding them, to go to the Space Nuts shop on our bytes.com website, because all our goodies are there. You can go to the bookshelf and check out all these publications. Oh, by the way, thank you to everyone who's already bought a copy of the Turanian Enigma. And I've already had a couple of people message me back saying they loved it and that they did not pick the twist at the end, which is great.
Well done, Andrew.
And I really appreciate the fact that you have enjoyed the story and got a big kick out of it. So fantastic. While you're at the shop, you can also get a T-shirt or a polo shirt or a cup or a mug or a cap, anything you desire as a supporter of Space Nuts. You can find at bytes.com/Space Nuts. That's BITESZ.com. I don't know why we spell it that way. Somebody probably took the real stuff. But thanks for supporting Space Nuts in whatever form, most particularly listening to us, which still, after 199 episodes, we find extraordinary.
We do, absolutely.
It is one of the wonders of the universe, Fred.
Yeah. Yep.
All right, Fred, thank you so much. I look forward to your company on episode 200.
We've got to think about that.
Big plans.
We haven't told me about them yet.
Well, we were hoping to do something big for episode 200, but unfortunately, this pandemic got in the way.
Yeah, that's right.
It restricted our movements, but we will still have a great time. We'll figure something out. There might be, I don't know. We'll work something out. Fly by the seat of our pants, as we always do. Yeah. All right, Fred, thank you so much. We'll catch you again next week.
Sounds great, Andrew. Take care. All the best. Look after yourself and see you soon. Fred
Watson, an Astronomer-at-Large, half of the team here at... Well, 1/3 of the team. I keep forgetting Hugh. Sorry, Hugh, the producer. But yeah, part of the massive team that is Space Nuts. And from me, Andrew Dunkley, thanks for your company. Catch you next time.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at bytes.com. This has been another quality podcast production from bytes.com.